Alright, this is the video lesson for 7-2, elimination using adding and subtracting. Now, one thing to keep in mind is we are still in the chapter called solving, I'm writing this in the name spot, solving systems of equations. So understand that we're still solving systems of equations. This is what we've been doing for the last 2 chapters actually. And we're just learning new ways to solve systems of equations. So again, if you look at our examples down here, we're still solving 2 equations, which means you're still going to have a graph. You're still going to probably have, or you're still going to have 2 lines that cross most likely. And if they do cross, they cross at one exact point, and that's what we're looking for. That is the solution to the system of equations. So keep that in mind through all this, that you're still talking about 2 equations, 2 lines. You still might get parallel lines, which we know parallel lines don't cross, so there is no solution. So you have to understand what the big idea is to these problems. And then remember that we're just learning new methods to solve these problems so that we don't have to graph every single equation. So in this in this instance, we're solving equations using elimination, and all elimination is going to do for us is it's going to give us that exact answer, that point where the 2 lines cross. It's going to give us that solution by either eliminating the x variable or the y variable right off the bat. So let's just get right into our examples here. If you look at problem number 1, the first equation here is negative 3x plus 4y equals 12, and the second equation is 3x minus 6y equals 18. Again, obviously 2 different equations that you're going to have to, if we wanted to graph this, you would have to put them both in y equals mx plus b form and graph them. But again, we're not going to do that. We're not going to graph these problems anymore. We're going to solve these another way. And today we're learning the elimination method. Alright, so what you're going to do with the elimination method is you're going to look at these 2 equations right on top of each other, and you're going to say, hey, can I eliminate the x's or can I eliminate the y's right now the way they are, using either addition or subtraction? And what you might notice here is that you might say, hey, if I add these 2 equations together, a negative 3x and a positive 3x is going to turn into what? Well, it's going to turn into 0. So it's just going to eliminate. You're going to have 0 x's, which you know that we don't need to write 0x. If you have none, they're just gone. Negative 3x plus 3x just cancels here, and they're gone. So now you have 4y plus a negative 6y, which we know is negative 2y. And then you have the 12 plus the 18, and again, you got to say that plus in between each problem. So 12 plus 18 gives me 30. And then you just have a basic 1-step equation to solve. I'm going to divide both sides by negative 2, and that's going to give me y equals negative 15. So that right there is my first answer. That means that I know right off the bat that this system of equations is going to have one solution, and that one solution is going to be something comma negative 15, because you just found that the y was negative 15. Well, at this point, this is the same process that you have back in the substitution method that we learned in the last section, and that is you're going to take this y equals negative 15 and plug it into either the first equation or the second equation, and it does not matter which one you choose. I'm going to go ahead and use the first equation. So I'm going to take this y equals negative 15 and I'm going to plug it into the first equation for y. Again, I'm going to put it right in there for y, and I'm going to rewrite my first equation. So my first equation now says negative 3x plus 4, but instead of times y, it's times negative 15, and that's going to equal 12 still. So equals 12. So here's my new first equation once I've plugged negative 15 in for the y. At this point, you just go about solving it. I have negative 3x. 4 times negative 15 is negative 60. Equals 12. So I add 60 to both sides. I have negative 3x equals 72. And then I'm going to divide both sides by negative 3, and x equals, and double check this with your calculator, but this should be negative 24. So there's your x, there's the y that you found earlier. So your solution is that these two lines are going to cross at the ordered pair negative 24, negative 15. Now this problem right here is a great example of why we learn other methods of solving, because I'm not going to want to graph these two equations and have them cross way down at the ordered pair negative 24, negative 15, because that's going to be a huge graph, and I'm probably not going to have enough graph paper to do that. So there you have it. There's one of the reasons why we learn these other methods. Alright, so problem number 2. Looking at this one again, and again, you're trying to decide, can you eliminate the x's or the y's? And in this case, you actually could eliminate both of them. It says using addition or subtraction, and if you used subtraction, x minus x would be 0, right? So that is a possibility, and we'll talk about some subtraction problems here in a little bit. But for right now, I want you to notice that instead of doing the x's, look at the y's right here, because one's already positive and one's already negative, which means you're going to be able to just add these two equations together. Remember, as long as you have opposite signs that are the exact same number, they're just going to eliminate automatically. So here I'm going to add these two equations together. So 1x plus 1x gives me 2x, and then negative 1y plus 1y, that's the cancels out, and then 14 plus 20 gives me 34. So again, I'm going to divide both sides by 2, and in this case x equals 17. So again, there's one of my answers, x is 17. And again, plug that into either of the two equations. I pick the first one a lot. If one's not easier or harder than the other one, I just usually tend to pick the first one. So I picked the first equation, and I'm going to rewrite it. Let's draw this arrow actually to where it actually goes in. X is 17, so I'm going to plug this in for the x. So I'm going to write 17 minus y equals 14. So to solve this, I subtract 17 on both sides. So I have negative y equals negative 3. The negative y means negative 1y, so I'm going to divide everything by negative 1. And y equals positive 3. So there you have it. There you have this answer, and this, again, is going to be a one-solution answer, meaning these two lines cross at one point, and that one point that they cross at, that one ordered pair that they cross at, is 3, 17. So there you have it. Alright, so there you go. There's our first two examples. Pretty good there. Let's clear this off and look at the next two examples. Alright, now, like I said, we're going to get into some of these where we are going to subtract. And I'll show you why we subtract here in a minute and what we actually do with a subtraction problem. So looking at number 3 here, we're trying to find something that can eliminate. Well, you're going to notice right away that both of them say 4x. But keep in mind that you're not going to add these together, because 4x plus 4x would make 8x. I don't want them to make 8x, I want them to make 0x. I want it to cancel. So instead of adding, you're going to say, okay, well, I subtract, because 4x minus 4x is 0. And that's exactly right. You will subtract then. Now, when you subtract, though, when you do this subtraction, you got to remember that your next step, you're going to have to subtract also. So you're going to say positive 2y minus a negative 3. And minus a negative turns into a positive. So, because of this, and because a lot of people forget that when you're subtracting and you have a minus a negative, you got to add, I actually say that anytime you need to subtract, and this is what I want you guys to do, anytime you need to subtract, I changed my symbol from addition, or from subtraction to addition. Now I have add, and if I change all the signs, then this positive 4x turns into a negative, the negative 3y turns into a positive, and the positive 18 turns into a negative, and now I just have to add them together. Adding them together here, 4x minus 4x is what cancels out. 2y plus 3y is 5y. And 28 minus 18 is 10. So you got 5y equals 10. Should be pretty simple to solve. Divide both sides by 5. Y equals 2. Good. So you have your one answer. You have your y part. So now we're going to take this back up into the original problem. And we'll erase some of this work that we've already done. And I'm going to say, okay, well, let's take that 2 and plug it in for one of these y's. Again, I'm just going to use the first one because it just seems to be as easy as anything else. So I'm going to rewrite that first equation as 4x plus 2 times, and instead of y, my y is 2, so 2 times 2 equals 28. So I have 4x plus 4 equals 28. Subtract 4 on both sides. 4x equals 24. And divide both sides by 4. And we get x equals 6. So there's your answer. This system of equations has one solution. Again, it has the solution, has one solution, and the solution is 6, 2. Alright, last regular problem here, and then we get into some story problems later in this section. So last regular problem. Again, I look at this and I notice right away I have a negative 4m and a negative 4m. Well, that's great that they're the same, but I actually want them to be opposites of each other, because negative 4m minus 4m is negative 8m. And again, I want that to turn into a 0, not a negative 8. So what I'm going to do is I'm going to say, okay, well, I'm going to have to subtract then, because subtraction means adding the opposite. So again, I changed this problem into an addition problem, and I then changed all the signs. Sorry, this keeps pausing. I'm not sure why exactly. So anyhow, I change all the signs because that's what subtraction is. Subtraction is adding the opposite. So I made this a plus problem, and then I changed each of these signs. So now I can subtract. Negative 4m, positive 4m cancels out. That's my 0. You then have 2n minus n, which is just 1n, equals 6 minus 8, negative 2. Alright, that was easy. Done already. N equals negative 2 is the first answer. So, we take this n equals negative 2, and we're going to plug it back into one of these original problems. Now, in this case, I'm going to plug it into the bottom equation, because that's just a single in there, so it seems like this might be a little bit easier to do. I have negative 4m, and then instead of plus n, I have a minus 2 equals 8. So we're then going to add 2 to both sides. So negative 4m equals 10. Divide by negative 4. So m equals 10 over negative 4, which we know simplifies into negative 5 over 2. So there's my m. And again, you remember ordered pairs are always x comma y, which means ordered pairs are always in alphabetical order. So this answer will be m comma n because of alphabetical order. So this system of equations again has one solution, and that one solution is negative 5 over 2 comma negative 2. So there you have it. Now you might be asking yourself the question, well, what happens since I'm talking about systems of equations, and I know that systems of equations are two lines graphed on the same xy axis. Well, what happens if I get parallel lines? I'm supposed to get no solution. Well, what does that look like in a problem like this? And that's a great question. And the answer to that is you know that in other problems that we've done, if you're doing an algebraic problem and all of your variables, let's say this is, I'm just going to do a squiggly line here for our algebra problem. If all the variables cancel and you end up with something like 2 equals 8, you remember that any false statement means no solution. So if your variables all cancel out, everything's gone, and you get a false statement, well, that's a no solution. And then in the same sense, if you get a true statement, like 2 equals 2, true statement, that's going to mean infinitely many solutions. So we will look at some of those examples here in class and during homework time too. So keep that in mind. All right, very good. So that's the video lesson for 7-2 elimination using addition and subtraction. There is a part 2 to this video that will cover the story problems from this section. Thank you.